Alright, this is Computer Science 305, Programming Languages. This is Lecture 8, Syntax and Semantics, my solution to the in-class exercise. So we start out with this grammar, which was an expression grammar that we showed was ambiguous as part of the out-of-class exercise. And then for this, because the goal of this is to remove the ambiguity and, and then validate that it's for certain no longer ambiguous. And so what we can do is we can say we have to have a couple assumptions here. First off, we have two operators, multiplication and addition. And the goal is we're going to make the assumption right now that they have the same precedence level. And we're also going to make the assumption that both multiplication and addition are left associative. So in order to do this, we first need to redefine it because we need to remove we need to adjust it such that there isn't, for each one of these operators, two recursive rules that call exp. So in order to do this, we need to break it down such that there is a secondary rule providing or removing that extra ambiguity. And so what we can do is we can simply say exp, and we'll leave both multiplication and addition on the same precedence level, but we will move the parentheses to a higher precedence level because, well, they're typically higher precedence. In order to do that, what we'll do is we'll say, since we're maintaining left associativity, we will say, we'll call it root is our new, will be the name of our new rule, and we'll root. And then root will contain the parenthesized form as well as the variables. Alright, so now that we've done that, we should be good to go. Let's validate by constructing parse trees that actually represent this whole thing. And so we'll start out the rule that we showed, or the string that we showed that would make this ambiguous would be, for example, a times b plus c. And so if we start out with just exp at the top, we know that we'll make the assumption, we'll start out, can it go to the left? And our goal should be to say which will, if we do this starting at the top, we get the same resulting parse tree. So we take a look, and it's a times b plus c. So we know that a, b, and c will have to come out as they're all from root. So root exp, root exp, and then we know that the multiplication comes from exp itself, which exp then has a single exp off to that side, which then can go to root, which then becomes a, and the other side is root. So this one just goes straight down here. So that solves the first half of this part, which then has a line that goes down to plus, and then the other side goes to a root exp, and it goes here. So we can show that that is grouping to the left as expected for our left associativity. Well, let's try to see if we can generate a second one that fits within the possible tree. So we have a times b plus c. So the thought would be, well, we could generate a parse tree that fits with this, such that B plus C would be a part of the same group. So we would say that B would come off of root, C would come off of root, right? And then this would be from an expression, and we have an expression here, here, and here, like this, right? And that we would have some way of starting with an exp at the top, which would then go to an exp root, and then A, and then this expression would come down there like that. Except for the problem is we have no way to go from expression to the expression over here, because it would automatically go to a root. So we cannot make this tree actually occur. So this doesn't actually happen, and we can only generate this single tree for that expression. So well, that solves that. Well, in reality, we can never gain any other type of tree, because we removed any type of possible ambiguous recursion in our rules. So we validated that. So we have only one way to do this. This is not the only expression in the language, of course. There are many other expressions, but this is the simplest one that should have gained immediate ambiguity, and we did not generate that from our language, and therefore we can assume that this is unambiguous. Furthermore, we know that it's not ambiguous because of no double recursion. So that's how we solve that and validate it, at least for this time being. I look forward to seeing you all in class. Have a great day.